What's going on? Got another video here for you. We are going to find the limit as x goes to infinity of x times natural log of x plus 1 minus natural log x. Alright, so let's look at this. So if we take the limit as x goes to infinity, well, this x out here, that's going to infinity. And this natural log here would go to infinity. This natural log here would go to infinity. So in the parentheses here, we got infinity minus infinity. That looks like 0 times infinity is 0. Of course, you know we can't do that. All right, so how would we go about working this? Well, I think it would help to kind of rewrite this thing. Whoops. Let's write this. The limit as x goes to infinity of x times. Now let's use our logarithm properties. That's going to be the natural log of x plus 1 over x. All right. So remember, we have a property that says if we're subtracting, we can bring this together as one log and divide the two. Okay. And so now we have what? We have the limit as x goes to infinity of x times 1 plus 1 over, natural log of 1 plus 1 over x, right? This would be x over x plus 1 over x, and x over x is 1. All right. Now let's look at this. Well, we've got as x goes to infinity, let's look at this in here. This term right here would go to 0 because the denominator's getting really big, and we would have the natural log of 1, which is 0. 0 times infinity. Well, we can't have that. So let's rewrite this. The limit as x goes to infinity of natural log of 1 plus 1 over x over 1 over x. So I just rewrote this x here in the denominator as 1 over x. Because think about it, if you took just this part here and you did this divided by this, that's the same thing as the numerator times the reciprocal of the denominator, which would give us that back. All right. All right. So now if we look at this, if we take the limit as x goes to infinity, well, this right here, up here, that goes to 0. We got natural log of 1 is 0. This down here, x goes to infinity, so that whole fraction right there is going to 0. So we got 0 over 0. And that tells us we can use what? L'Hopital's rule. So this is going to be the limit as x goes to infinity. The derivative of the numerator, that's 1 over 1 plus 1 over x, times the derivative of what you're taking the natural log of. So the derivative of 1 is 0, and the derivative of 1 over x is negative 1 over x squared. So just remember this. I've explained this in other videos in case you haven't watched them. If you have y equals just any number over x, that derivative is going to be negative that number over x squared. And the way we do that, we can rewrite this as c times x to the negative 1. And then if we use the power rule, you get the negative c over x squared. And this is a 1 up here, so it's just negative 1 over x squared. All right. Now, that's the derivative of the numerator. Derivative of the denominator is negative 1 over x squared. And you can see here that this and this cancel. So we're left with the limit as x goes to infinity of 1 over 1 plus 1 over x. And then as we take the limit as x goes to infinity, this term right here goes to 0. So we're left with 1 over 1, which equals 1. And there's your answer. So I hope this video helped. Check out my other videos. Give me a like, share, subscribe, comment, and I will see y'all in the next one. Later.